This is Essie Jewell. The date is 7/11/15, and this is my lesson plan for AP Biology, sections 1 through 3. For my Common Core Standards, I have chosen CCSS.ela-literacy.rst.9-10.9, which is compare and contrast findings presented in a text to those from other sources, including their own experiments, noting when the findings support or contradict previous explanations or accounts. The learning objectives for AP Biology are very specific and laid out for us in advance. Since this is the first lesson, I have chosen Learning Objective 1.27. The student is able to describe a scientific hypothesis about the origin of life on Earth located under Big Idea 1. Essential Knowledge 1.D.1. Scientific evidence from many different disciplines supports models of the origin of life. College Board Workshop Handbook and Resources 2015 through 2016, page 20. By the end of this lesson, students will be able to demonstrate knowledge of the following key concepts. List or define geological evidence supporting the models of the Earth's approximate age. List or define evidence that supports the range of dates for the origin of life. Show chemical evidence that demonstrates complex organic molecules can be formed from inorganic molecules in the absence of life. List or define the molecular building blocks that are common to all life. Discuss the concept that there is a common genetic code for all life. The reason I've chosen these objectives is in order to build a foundation for more complex material. Although my students in all likelihood will have been introduced to many of these concepts in previous courses, I want to make certain that everyone starts out with the same basic understanding of the current theories of the origin of life. Students come in a variety of ethnic, academic, and socio-economic backgrounds. In order to level the playing field for the success of all my students, I need to make certain that everyone starts out with the same basic knowledge. This lesson plan will be the first open inquiry lab for many of my students. I chose this one for the first open inquiry because it is a simple lab. Hypothesizing about what will happen when conditions are varied should be simple and easily understood with proper instructor guidance. For my student grouping, I will lecture to the entire group, followed by explanation of the lab purpose and procedures. Students will then split into groups to demonstrate how organic molecules, specifically amino acids, could have come together spontaneously in Earth's primordial oceans to form coacervates, which scientists believe that the earliest life was probably much like coacervates, which are unbounded systems, also known as protocells. Students will also use open inquiry to hypothesize about changes such as heat, pH, light, etc., that could change the output of this experiment. Students will keep a log of their experiments, turn one copy in, and keep one copy. Students will then reassemble and will discuss what they have seen and learned. I will use formative assessment to determine understanding and correct any misinformation. I've chosen to lecture to the entire group as well as give explanations and demonstrations of proper techniques and procedures in the lab because I believe this is the most beneficial to students. For hands-on activities, or in this case lab experiments, I believe small groups work the best. Students need to be able to see and do the exercises for maximum benefit. Cooperative learning, those in small groups, is beneficial since it allows students to discuss what is happening as they proceed through the lesson. Students gain confidence by seeing and doing and being able to talk about what's happening. Class discussion will give me a grasp of what level their understanding is at and will allow me to correct any misinformation. The teaching strategies that I will use for this lesson include lecture, assigning homework, which will include reading and answering questions, setting learning objectives and providing feedback through formative assessments, providing cooperative learning in the form of small lab groups and in-class discussion, non-linguistic exercises including drawing of the lab results, summarizing and note-taking in the form of lab reports as well as lecture. I've chosen these methods for a variety of reasons. I've assigned the reading and homework questions to ensure students are prepared to work when they come to class. Stating the learning objectives gives students the direction that the lesson will progress and what key concepts to be on the lookout for. Cooperative learning allows students to brainstorm, to share ideas, and to assess concepts in greater depth. Drawing the results of their experiments as well as reporting the results fixes the lab in the student's mind and helps achieve greater understanding. Formative assessments ensure that the students stay on track and that any misinformation is kept at a minimum.